within CBTN, we've been really thinking about federation for almost about 5 years, and what it takes to federate and why to federate. As I was getting ready for today, I was sort of reflecting on federations overall. And some of you may know, right, that the Articles of Confederations were ratified initially in Philadelphia for the birth of the United States, but that was a confederation. And a confederation is actually really a loose agreement among institutions that they're willing to work together, but they actually don't have sort of shared commitment to follow each other's practices. Some may argue that states today still don't have shared commitment to that extent, but the founding fathers did recognize the challenges of a confederation, and as part of their meeting in 1786, they decided to switch to a federation. And this actually, if you read the history books, many people who came to that meeting didn't know they were signing up for a federation at the time, but it turns out that this was a really novel idea from a country perspective, and remained challenging even after those meetings. It took almost a year to actually ratify the Constitution, which was drafted at the time. And Hamilton and others had to write the Federalist Papers to convince the states and others that being a federal entity that was federated made sense. And it's in part because it's very challenging, to support diversity of stakeholders that may have both shared interests and needs, but at the same time, want individual sort of governance and setting. And so if you look at across the landscape of governance, it goes all the way from many small, siloed, separate efforts to large-scale unitary states, and everything in between. This is the official definition from Wikipedia, that it's a union of partially self-governing provinces or regions, or where the power is formally divided between a central governing framework and a number of constituent regions that have a vote, typically majority vote, around how things are operated. So federation really sort of sits in this middle space between providing sort of autonomy and enterprise on behalf of the individual stakeholders, while requiring those individual stakeholders to align to some basic principles that are required to make the whole greater than the part. As you can tell, CBTN has been practicing federation for some time, but in a really unique way, if you think about it from this perspective, and this will come back to some of the questions around MCI and some of the other efforts. Because in order to really operationalize this methodology of going from centralized biospecimens to data that then becomes structured information that's queryable, to ultimately knowledge, and then ultimately impact, you have to traverse this analog to digital divide. And it's almost impossible to federate the analog, meaning it's very hard to constantly assess analog states by just having to go to those spaces and measure. So for example, the way that the United States, when it was first born, managed it is that during elections, right, you don't actually count each individual vote. You have somebody, right, on behalf of all those individual voters who is communicating your particular state's vote, for example. So that was the way they managed the analog space at the time, in ways that I think was legitimate for that time. But we had to manage a centralization of biospecimens, but at the same time invoke federation, meaning that even though we were centralizing biospecimen, the governance was federated, right? The governance was not linked to the fact that the specimens were stored at CHOP or the biorepository. The institutions themselves had governance, and in fact, the entire global community had access. And whether or not we knew at the time, that's a very novel framework of essentially segregating or splitting the analog centralization from the digital federation of resources. And it's positioned CBTN to really inform the development of new types of structures for the NIH that really look at this idea of centralized federation. And this is an oxymoron for most people, but I think you guys are comfortable with combining unique entities together as part of CBTN. It was aligned with these principles of maximizing discovery through non-local interactions that maximize the number of users, that support maximal diversity of those users, that maximize the connectivity between those community stakeholders, and support as frictionless flow of data and information. And if you read about infrastructure that's tried to map federated infrastructure from governance into data, you'll start hitting a lot of theoretical narratives on what's best. Is it better to decentralize data sets? It's better to centralize data. Should the data be distributed? And what are the tools and resources? But inherent in all of these, it's not the right answer for everything, is that the key is connectivity and interoperability between those resources. So it turns out that federation is hard. And because it's so hard, even with the advent of the internet and a digital transformation across the globe, most entities still choose to centralize because it's almost always easier to invoke a technical solution than a social solution. And so people default to centralizing their data within their institutions or even within the government. But it turns out that that ends up missing the technological revolution that is upon us. And this is actually from a recent blog that I just pulled, where this technologist was essentially going through federation and the timeliness of it. In theory, if it's digital, you should be able to just query it across different resources, right? You don't have to centralize it. You should just send a query here and a query there and get your answer. We should be able to ask the question across all of our institutions: how many DIPG patients exist at this moment in time in your EHR? EHR is digital, right? Hypothetically, right? The data is digital and should be flowable. But it turns out that nobody can actually do that. And it's not unique to healthcare. So even if he gave the example here of a grocery store sort of manager that was trying to figure out online purchase transaction and in-store purchase transaction, it seems simple that you should just query, combine, and get an answer. But no matter what you have as a plan, when you actually try to do it, you end up getting punched in the face. And this has been a recurrent framework for almost any federated effort over time, that it's almost never as simple as it looks, because it's not just about a digital, it's about matching the digital with the social and community stakeholder governance framework. You actually have to match social governance with technology governance and put the pieces together. And so despite the promise of technology, his quote was that data federation just moved further and back. And as people were able to store more and more data, they just create bigger and bigger silos for their own data in many efforts. But what really has changed, and we've been trying to capitalize on this within CBTN since 2016, is that the cloud came along. So the cloud is an environment that supports the 9 local storage of information, but allows you to actually apply differential governance and access to resources. And as long as you're willing to implement common standard and define a governance structure for it, you can actually federate in ways that align with CBTN principles. And so the key for this is that you have to match governance, security, and transparency with data standards. And part of the reason I'm bringing data standards because you see how we've sort of been tackling standards on the genomic front, right? We've been harmonizing large-scale data sets for CBTN with the first PBTA, which you'll hear about, this second EXO1 data, the proteomics data. On the genomic side, we can harmonize A, T, Cs, and Gs. We can get to standards around those letters. And on the clinical side is some of the hard part that Sarah and Angela have also been talking about, is establishing standards on the clinical side, so that if we agree on standards for what answer you should get back when you ask that question, if you ask the question, I want a peanut or something else, the system ought to know, right? Or connect between those, or we should harmonize between those data sets. And it turns out that this is actually important, because I'm just going to show you a standard example of federation here. So if you go to Google and you say flights, so the idea here that if I'm asking for a flight to San Francisco, and I search, What Google's actually doing here is it's federating a query across all the airlines and asking, give me your schedule, for a flight from DC to San Francisco. Google is actually not storing or centralizing all the data within Google. What Google and many others required is each of you airlines, you have to give me the answer in the same way. And if you give me the answer in the same way, I can present information for you. And you can see it was instantaneous. And that's because each of the airline maintains their own cloud infrastructure, right, for all of their services. But Google can talk to it and via what's called an application program interface, interact with that data. Come back here. So because we essentially leveraged CBTN as the foundation data set to design the Kids First platform and resources around it, we're really in a unique position to work with the NIH around this idea of how do we do what Google can do for airlines for data. And as part of the Kids First program, the NIH launched a cloud interoperability effort because it turns out that even across NIH, you have data stored in different locations, and you have to connect between them. And so over the past 2 years, we've been working as part of the NIH to develop this interoperability framework so that if you're in one system and you ask the question, I want all data for this type of brain tumor, there's data that is within CBTN, but there might be data that's within NCI or MCI. As an end user, I don't care where the data are. I don't want to have to go hunt and peck for that data in different places. And so we've been piloting this effort, and through funding from the NIH, have operationalized this idea that through an application program interface, the same type of technology that empowers airlines to communicate their data, we can ask this question in the cloud across data sets through Kavatica. Let me show you that just briefly, if I can. So here's the OpenPBTA data. And you'll see, I think one of the presentations from Deanne Taylor, she wanted, and the NCI wanted to intersect CBTN data with GTEx data. It doesn't make any difference, what GTEx is. But the important part is that traditionally, in order to do that, you would have to go to different sources, authenticate and authorize differentially across those different entities, figure out how to get that data, download the data, and bring it all together. But because we've applied standards that align with new NIH requirements, I can now simply get a list of those files, and I can simply bring that list into Kavatica. And the system itself understands, just like Google does. Are you, Adam, supposed to have access to these data? Let me communicate your access to the system. And in real time, rather than moving the data, right? Google doesn't copy the entirety of the database from these airlines. It just says, virtualize that information for me. Kavatica essentially does the same thing. And in a couple of seconds, will represent essentially millions of files that are coming across two different systems on behalf of an end user. So where it says DRS, here suddenly, just like those airline communications, these are the actual files, genomic files, that are now intersectable with CBTN data. I mean, even though they're not co-localized in the same location. So why am I talking about all this? Because we can do this now for files. The next challenge is how do we do that for clinical data, right? So we can do it for files, but you need to attach files to clinical data at the same time. As part of the NIH effort and within CBTN, we've been leveraging a new technology implementation called FHIR, and this is stands for Fast Healthcare Interoperability Research, and Alison Heath later today will talk about this. And it's a new mandate actually under the Cures Act that supports essentially the exchange of clinical data between systems in the same way that I just exchanged large-scale file data. So suddenly we are now poised to say, give me your genomic file from MCI, give me your clinical data from Seattle, bring this together in real time in a common space without constantly having to centralize. Now, That's not yet possible, to be clear, and I think Allison, somebody was raising their hand, not yet possible, but CBTN is leading the development of those resources for the rest of mankind as part of our framework that harnesses our existing shared federated governance language. So because we have shared federation of governance, we can now begin optimizing the technology that will empower the next phase of those resources. And so this comes to Sabina's question. How do we do this longer term, right? On the screen, I just tried to capture some of the existing neuro-oncology landscape that has emerged. And the reality is that in some cases, it makes sense to bring data together. You have to harmonize it. You have to actually compute against it. In other settings, if the community itself aligns with the technology and applies that technology through their ecosystem, then we can apply the right governance, authentication, and resources to connect across data sets. And so we were fortunate enough, because of this commitment to interoperability and sharing, to receive an NCI contract to pilot this for the next year across CBTN, PCDC, Treehouse, and the St. Jude Cloud. These with the idea that, yes, we know how to centralize data. We know how to just copy data and bring it into one massive environment, but that is not a scalable long-term solution. And it's not a realistic solution as related to human infrastructure, right? Humans need their own efforts and dedicated spaces, but at the same time, they can't lose on the opportunity to discover through siloed resources. And because this cloud-based technology empowers transparency, auditing, and security, there's no longer any excuse not to do it as a community. And it's this resource that sets us really at the precipice of trying to tackle the question that Sabina asked. Part of this experiment will be exactly what Sarah just described, because the last partner is COG. So if a child is enrolled on CBTN and on Project Every Child, which is by and large the case for most of Sarah's cases, and MCI generates data for that child, and CBTN generates data from the specimens and clinical data for that. As an end user, you will not know the difference because the CBTN's infrastructure is going to connect across that. And that's the pilot for the next year, is to show that we as a community can commit to leveraging resources coming from the NCI, from foundation partners, from institutions, to prioritize and connect across those efforts without duplicating essentially the efforts and optimizing on what's right for patients, as Sabina mentioned. Because it should be the case that if you know that this child has a whole exome by MCI, you don't generate it again on CBTN. Or that if a DIPG trial in PNOC already generated data on a specimen, you're not trying to leverage essentially that specimen for something else because it's being used elsewhere. And I think we're poised because of our federated commitment from the very early stages as a CBTN to match technology to implementation. And over the next year, we'll actually be doing the experiment for the very first time across the national landscape, allowing any patient and parent and researcher or clinician to pilot this connectivity initially across a couple of institutions and hopefully longer term across all institutions. And the key here is that what changes when you federate is time. So the minute you can federate through technology, what you gain is time, because that's what it takes to centralize. Centralization requires time and effort in ways it doesn't scale. If you're willing to federate through infrastructure, you can get near instantaneous virtualization of data, right? If I wanted to copy that data from GTEx into my workspace environment in Cavatica, it would have taken me a month to do that. That would have been how long it takes to centralize data from another endpoint into my computer environment. But because we piloted ways to federate and connect and authorize, it took me 5 seconds to do it. And that's the key. for the next phase.